I received an email a while back from Marcus Jenkins, EA5IGC, about an amplifier module he's designed. He said he got the idea for a cascode gain stage with a bootstrap follower from the WWV receiver video I did. I'll put a link to that video down in the description. So Marcus designed this amplifier module and had some nice printed circuit boards made up. He has a nice write-up about his design on his website, and I'll put a link to that down in the description too. He was also kind enough to send me one, along with this beautiful QSL card. So thank you very much, Marcus. Now let's build it up and see what it can do. The board in the schematic made for an easy build. Nice job, Marcus. After getting the amplifier built, I hooked it up to my spectrum analyzer here to see what it can do. I was surprised to find that the performance of this unit was nowhere near as good as what Marcus found. So I double-checked my work against the schematic, and everything looked all right. As I was looking at the schematic, though, I noticed R10 here. It seemed like kind of a large value, which made me wonder what the collector current on Q3 was. The reason I wondered is because the output impedance of an emitter follower depends on its gain. And the gain, in turn, depends on collector current. Now, if Q3 has a high output impedance, it'll still be able to drive a high impedance load like a scope with no problem. But driving the 50 ohm load that my spectrum analyzer presents requires a reasonably low output impedance. So I had a look at the R7, R8 divider to see what the bias voltage is. 22 kilo ohms times 12 volts over 69 kilo ohms comes out to 3.8 volts. Less a diode drop is 3.1 volts across R10. That's only about 460 microamps. And the 3904 makes its best gain with about 10 milliamps of collector current. Now, the collector and emitter current are about equal if the gain is decent. So let's go for 10 milliamps of emitter current. Then the base current might be as much as 100 microamps, assuming a gain of 100. So that's a 100 millivolt drop across R9, no big deal. But the voltage sag at the R7, R8 divider would be like 2 volts, which is no good. Switching R7 to 4.7 kilo ohms and R8 to 2.2 kilo ohms gets us in the ballpark. Then the divider will droop about 200 millivolts under load. That plus the 100 millivolts across R9, and the diode drop is about a volt. That gives us 2.8 volts at the emitter. Now we can see that changing R10 to 270 ohms will give us about 10 milliamps of emitter current. So I changed out R7, R8, and R10 for the new values. And it runs great, driving the 50 ohm load with no problem. Now we can see results similar to what Marcus found. I had fun building this little amplifier, and it will be a handy thing to have around the shop. So thanks again to Marcus for the board and the QSL card. If you enjoyed this video, please give it a big thumbs up, and if this is the kind of thing you're into, hit that subscribe button.